Welcome back to Java Internals Crashcasts. I'm Sheila, and with me, as always, is Victor. Today we're diving into an exciting topic in our Advanced Topics season, VarHandle and Enhanced Atomics in Java 9+. Victor, are you ready to handle some variables?
Absolutely, Sheila. I'm excited to discuss these powerful tools that have significantly improved Java's concurrency capabilities.
Great. Before we get started, listeners, make sure you're familiar with basic concurrency concepts and atomic operations in Java. Now, let's kick things off with a quiz question. By what percentage did VarHandle improve the performance of certain atomic operations compared to the older atomic classes?
Ooh, that's an intriguing question, Sheila. It really highlights the impact of these new features. Without giving away the answer, I think our listeners will be surprised by just how significant the improvement is. It's a testament to how much thought and engineering goes into each Java release.
Absolutely, Victor. Now, let's start with the basics. Can you explain what VarHandle is and why it was introduced?
Certainly. VarHandle, introduced in Java 9, is essentially a typed reference to a variable. Think of it as a smart pointer that allows efficient, low-level access to variables. It was introduced to provide a standard way to perform atomic and memory ordering operations on variables, whether they're static, instance fields, or array elements.
That's interesting. So, it's like a more versatile and powerful version of the Reflection API?
That's a great observation, Sheila. While there are similarities, VarHandle is designed to be much more efficient. Unlike Reflection, VarHandle operations can be fully optimized by the JVM, making them suitable for performance-critical code.
I see. Can you give us an example of how we might use VarHandle in practice?
Of course. Let's say we have a counter that needs to be accessed by multiple threads. Instead of using atomic integer, we could use a VarHandle. Imagine we're creating a special type of counter that can be safely updated by multiple parts of our program at the same time. We'd set up a VarHandle for our counter variable, which allows us to perform atomic operations on it, like incrementing it safely without conflicts.
That's really neat. It seems more flexible than the old atomic classes. But speaking of those, how do the enhanced atomics fit into this picture?
Great question. The enhanced atomics in Java 9+ leverage VarHandle under the hood. They provide new methods that offer more control over memory ordering, such as getPlain, setRelease, and compare and exchange. These allow developers to fine-tune the balance between performance and visibility guarantees.
That sounds powerful, but also potentially complicated. Are there any pitfalls developers should be aware of when using these new features?
Absolutely, Sheila. The main pitfall is the increased complexity in terms of memory ordering. With great power comes great responsibility, as they say. Developers need to understand concepts like happen-before relationships and memory fences to use these tools effectively and safely.
I can see how that might be challenging. Do you have any tips for developers who are just starting to work with VarHandle and enhanced atomics?
Certainly. My first tip would be to start simple. Use the default memory ordering, which is usually what you want, unless you have a specific reason and understand the implications of changing it. Second, always prefer the higher-level concurrent utilities unless you have a proven need for these low-level tools. And finally, extensive testing is crucial when working with concurrent code, especially when using these advanced features.
Those are great tips, Victor. Now, I'm curious about real-world applications. Where might developers encounter or need to use VarHandle and enhanced atomics?
VarHandle and enhanced atomics shine in high-performance, concurrent scenarios. They're particularly useful in situations like lock-free data structures, high-throughput messaging systems, or any application where you need fine-grained control over concurrent access to shared data. For instance, they've been used to optimize the internals of Java's concurrent hash map.
Fascinating. It's amazing to see how these low-level improvements can have such a big impact on high-level applications. Now, before we wrap up, let's reveal the answer to our quiz question. Victor, would you like to do the honors?
Certainly, Sheila. The introduction of VarHandle led to performance improvements of up to 30% for certain atomic operations compared to the older atomic classes. This significant boost is due to VarHandle's ability to be fully optimized by the JVM, eliminating the need for intermediate objects in many cases.
Wow, that's a substantial improvement. To summarize today's episode, we've learned about VarHandle, a powerful new tool for low-level, high-performance variable access. We've also discussed enhanced atomics, which leverage VarHandle to provide more control over memory ordering. While these tools offer significant performance benefits, they also require a deep understanding of memory ordering and concurrency to use safely and effectively.
Absolutely, Sheila. And remember, while these tools are powerful, they're not always necessary. Always start with the simplest solution that meets your needs, and only reach for these advanced tools when you have a specific performance-critical use case.
Great advice, Victor. In our next episode, we'll be discussing improvements to completable future in Java 9+, so stay tuned. If you've enjoyed this episode, please subscribe to Java Internal's Crashcasts and leave us a rating. Your support helps us continue producing this content. Until next time, happy coding!